Thank you for giving me this opportunity. Really excited to be here. So I'll be talking about the purple theming AWS with CloudGoat and CloudTrail. So my name is Ashwin Patil. I think my intro is already covered. Again, I also wanted to thank Scythe and for organizing this particular summit. It's really a great platform to share the purple theming ideas. So I think part of my intro is already covered, so I'll just probably talk through the agenda. We have like pretty good packed agenda today. So we'll be starting with the introduction to CloudGoat. So if you have never heard of it or used CloudGoat, we'll be starting with scratch, what that tool is, and then how you can use it for purple theming. Then we'll be, as a blue teamer, I'm specifically interested for AWS monitoring. So we'll be talking about what are the data sources available, what is the ATT&CK Cloud Matrix available for AWS, and then we'll take a deep dive into CloudTrail architecture, and then what to look for from a threat hunting perspective. Then for the most of the talk we have selected 3 end-to-end attack scenarios. So CloudGoat has around 8 to 10, and then very recently, I think this week they released a new attack scenario on the EFS. So we have selected 3 attack scenarios here. So the way I have structured this is like we'll be simulating the attack scenario and then going back and then seeing like from a logging perspective, what events we see, what events we should monitor, how does the log timeline looks like, and then from all the exercises, what are the detection opportunities that you see, right? And then finally, we'll basically conclude the talk. All right, so if you have not heard of the CloudGoat, it's a basically vulnerable by design AWS deployment tool. It's published by Rhino Security Labs. It's completely open source. They do some of the best AWS research that I've seen so far when I started learning about AWS and what are the different attack cloud vectors presence for AWS, right? So CloudGoat is nothing but the collection of Terraform templates, which will basically give you capability to deploy, provision, and destroy the vulnerable resources via a single line, single command line Python interface, right? The best thing with the CloudGoat is it provides end-to-end attack scenarios instead of a single TTPs. So this really things put into perspective when you're starting to develop your monitoring strategy, right? So you can develop much more meaningful detections when you know the end-to-end attack workflow. In order to simulate the adversary behavior, they have provided the cheat sheets. So it's basically a series of AWS CLI commands that you can go ahead and execute to simulate that particular attack. Since we are talking about the vulnerable by design, I hope like we'll be using non-prod environment. If not, the CloudGoat also has capability to restrict access to vulnerable environment via allow list or via IP or subnet block, right? When you're starting with setting up the CloudGoat, there are basically 2 options. Either you can install Python dependencies, install relevant packages and all those things, or you can just get going with the pre-packaged Docker image, which has everything pre-built along with Terraform, AWS CLI, and all those things. So the Docker image is something which is like a very quick start for you to get started. Right. So the blue team talk is not complete without mentioning the attack framework. So this is the current attack framework for AWS looks like. Of course, if you have seen the other MITRE attack framework for enterprise, it has more tactics and techniques, more than 200 techniques available. So as you can see, this is fairly small. The MITRE emphasizes on making sure that it represents the real world cloud attacks. So as we grow further and we see like more and more case studies get published, we'll see this metrics gets bubbled up, right? So when you're writing any detections or looking for any TTPs, make sure you come back and see like if there is a technique available through which you can map your detections. So let's talk about the data sources that are available. The monitoring strategy is, of course, relying on what are the core data sources available. When you are talking about monitoring in the cloud environment, in addition to host or whatever the resources that you have, you also wanted to monitor the cloud-specific services, right? So EC2 or storage bucket and all those related activities, you want to monitor what all happening at the control plane and data plane, right? So on the core data sources, we have, let's see, we have a CloudTrail, which basically captures most of the AWS services. AWS has around probably around hundreds of services. Each of them supports a public API. So any API related activities will get captured into the CloudTrail. There is S3 is basically a storage component. So anytime your bucket is accessed or anytime the files inside that is accessed is going to get captured into the S3 access log from the data plane perspective. From the network logs perspective, we have VPC flow logs, load balancer logs, DNS logs, etc., etc. The security guard duty is basically AWS own built-in alert platforms that you can leverage when you're writing detections. There are also other relevant data sources that are worth considering, like CloudWatch alarms, web application firewall, or DDoS logs, and Messi, which is like machine learning service. So if you have seen here, most of the data sources have a preferred log destination as S3. So depending upon the same platform, or if you're collecting the logs in a centralized fashion, you may wanted to see what are capabilities available to ingest data from S3 buckets or directly hook to the CloudTrail. If you don't want to do the centralized log collection, Amazon also has their own Athena or CloudWatch through which you can query the CloudTrail logs. Awesome. So let's talk about little bit about the CloudTrail architecture itself. So when you're talking about the cloud platforms, I'm sure like if you have used the native on-premises event log services, you fairly know what happens behind the scene about the Windows event log or Linux syslog. But in the cloud, it's always get to know what is happening on the behind the scene. So this is a architecture which is relatively old, but it specifies the component very clearly. So let's start step by step, right? So I've started mapping each layer with what are the components, and then what are the CloudTrail field names that we will see to find that particular layer, right? So on the top layer, we have AWS Management Console, SDK, or AWS CLI. So when you're accessing the cloud services, either you will be accessing through a UI, which is like managementconsole.aws.com, or you will be using AWS CLI, or you have some application that will be leveraging the AWS SDK, right? So those are the interfaces that are available to access the cloud services. So if you wanted to monitor like what type of access being happening for your cloud services, the user agent field in the CloudTrail logs that will clearly show if it's a AWS CLI or if it's a browser console or an SDK application. The next layer here is all of the AWS services, right? So I mentioned there are like hundreds of services. So from the CloudTrail perspective, as of yesterday that I checked, there are around 167 services that are supported logging to the CloudTrail, right? The only one service that was mentioned here was the Trusted Advisor, which has a API, but it is not supported with the CloudTrail logging. And then there are some services which do not have public API, so naturally those will not get logged into the CloudTrail as well. Right. And then from the CloudTrail data source, that activity will capture into the event source field. So the next layer is the event type. So this is really a good way to bucketize your data source. So most of the events will fall into under these three categories. So you will have API activities, which will show event type as API call. Then there are like some non-API events such as a log on, and then there are CloudTrail insights, which is basically a service built on top of the CloudTrail, which will process and analyze your CloudTrail logs, and then try to create a baseline pattern. And then anytime it sees a large deviation from the baseline, it will try to trigger an event for any APIs. So it's something like similar to time series analysis. So the examples of API calls can be like create, describe, get, list, remove, delete, attach, detach, and there are also like lots of APIs respective to each service available. So you can go and check out the AWS documentation, like what are the API actions are available. From the non-API events, I have mentioned already, there are console sign-in events or there are AWS service events that will be fall under the non-API events. And then CloudTrail is basically a call rate insight. So these will get captured into the event name field. So just to summarize this, you will have API activity that will get captured into the CloudTrail events. When you're defining your logging strategy, you will have an option to enable per region, or you can have a multi-region trail, which is basically a best practice. So you can create a trail and then define the configuration as multi-region, and then you will specify the destination as S3 bucket. So this covers most of the architecture. So this will also help us when we go back and then check the logs so that we know what we are looking for and which fields we should look for. So a little bit about the CloudTrail schema. Again, when you're writing detections or doing any sort of threat hunting activities, it's always good to get aware of the data sources and underlying schema, and then what it constitutes, right? So only a few things to highlight here. The blocks with the I guess like light orange, highlighted with the light orange, are basically the fields which are having a nested JSON. So these fields will have their own nested JSON structures, which will have more data inside of that. So it's basically a JSON property bag, which will have more fields and more data captured inside it. So for example, user identity can be JSON block, and then inside that JSON block, you will have multiple attributes associated with the user identity, such as username or user ID, access key, or those things. Other things that we already talked about, the error code and error message is basically going to indicate if it is a failed API response or a successful API response. So naturally, for successful, these fields will be null. So anytime you want to see if there was a failed attempt to for a specific API, you should look for these two field names. All right. So we mentioned about the AWS Guard duty briefly a couple of slides back. So let's cover also what are the built-in detections available for AWS. The purpose that we are doing this is basically we know we don't want to reinvent the wheel. So when you're writing detections, you make sure that that is something not available already in the platform that you can leverage. So AWS Guard Duty has most of the findings associated with EC2 and IAM user. Unfortunately, this is not mapped to the MITRE attack tactics level, but these have common buckets which are familiar, such as backdoor, behavioral, cryptocurrency, recon, Trojan, unauthorized access. So as you may notice, some of these will be based on the CloudTrail logs. Some will require network logs, such as VPC flow logs and all those things. So, and then color basically indicates the severity that AWS has provided for each of these alerts. And then these are the AWS findings associated with the IAM user. All right, so before we deep dive or start our actual attack simulation, these are like general guidelines, what you should look for from a threat hunting perspective. As for most of us, the cloud data source itself will be new. So it's a good idea to basically understand what are the things that you should look for, right? So you will always start with the alerts if you are ingesting into the SIEM platform. If you are collecting guard duty alerts, or if you have your own schedule alerts in your SIEM platforms, always start with those data source first, because that will be less noisy, and then that may have already captured some of the suspicious activities. Afterwards, you can start seeing like what are the AWS services that were touched while doing the threat hunting. The other things that you can start looking into are basically any activity which are making changes to your resources and environment. So anytime you see a create, update, or delete, attach, detach, remove these operations, you should take a closer look what has changed, if this was an authorized change, and then if that change results into some kind of compromise or some kind of suspicious activity. Apart from that, I think the assume role is something very critical to monitor. So assume role is something similar to Windows run as. So you can temporarily assume a certain role to do certain operations. So naturally, you wanted to look for privilege escalations where a low privilege role is trying to assume a higher privilege role to do certain operations. So you can, whenever you're doing threat hunting, make sure you do a closer look on those operations as well. And then based on the services, you will have individual events access. All right, so let's start with the fun part. The first scenario is basically a cloud breach S3. So most of us have heard the Capital One breach. It has been a good real world case study so far when you have started doing monitoring, when you are starting defining your monitoring strategy. So from a CloudGoat perspective, you have basically three options. You will start deploying through CloudGoat command line interface. So it basically accepts two arguments. The first will be the action, which will be a create, list, destroy, and then the second will be the actual scenario name. Right. For the simulation, there is a cheat sheet available, which are nothing but the AWS CLI commands. So if you click here, you'll basically route it back to the CloudGoat GitHub. So you can see like these are AWS CLI commands that you can start executing and then basically simulate the adversary behavior. Before looking into the AWS CLI commands, let's understand this scenario a little bit in detail. So you have a attacker, which is basically yourself. You're simulating an attacker from a CloudGoat command prompt, and then you will basically, once you deploy the resource, once you deploy this particular scenario, it will create these necessary resources that are required for this scenario. That will constitute an EC2 instance with a website which is vulnerable to SSRF. and then you'll also have a highly permissive role which is given S3 full access to list the buckets and to exfiltrate the data outside AWS. So if you notice here, like there are various TTPs that starts popping up here. So the first will be the attack techniques T1190, which is basically exploiting a public facing application. The second one will be the actual command that you'll issue to the EC2 metadata service, and then get the role that is attached to this EC2 instance. The third will be you'll basically again initiate a request to dump the credentials for that role which is attached to this EC2 instance. This EC2 instance was attached with the highly permissive role, so the credentials dumped will be for this the highly permissive role. So once you got the credentials, you can basically configure your AWS CLI profile to assume that particular role, and then do certain activities such as list bucket, identify the private bucket which contains the sensitive data, and then use AWS CLI to exfiltrate data outside AWS. Right. So these are the various TTPs that we have mapped here. Right. So I'll not show the actual attack timeline. Instead of that, we will just move forward and then talk about what are the API events that you should monitor, right? So as you have seen in the back, the previous diagram, there are various services that were basically used or in a malicious manner. So we have a IAM, STS, and S3 storage bucket. These are the services on which most of the API activity was performed, right? So these are some of the relevant API calls that are worth monitoring. So we have for the IAM, we have attach user policy, attach role policy, group policy. So this is basically anytime you have a highly permissive policy which is attached to a specific role or user, you wanted to monitor that, right? The another thing is when that role is basically attached to an EC2 instance profile, that is something that you should monitor for. Which falls under the defensive agent and then T1578 technique. From a STS perspective, we already talked about the assume role. So once you dump the credentials for the highly permissive role, you will naturally assume that credentials and then perform certain additional activity. From a S3 services perspective, we'll have some activities such as list bucket, list object, get object, get object. So let's talk about the timeline. So after simulating the commands, we'll go back and then look into the our CloudTrail logs to see like what is started showing up. Right? So as you can see, the first is the attach role policy. Now, one of the interesting thing that we should do is like using CloudGoat's own actions to identify and then write detections for the CloudGoat actions, right? So what I mean is basically CloudGoat is trying, as a part of the scenario deployment, CloudGoat deploys the vulnerable resource. So you can capture that particular activity so that next time if somebody is accidentally deploying a certain vulnerable resource, you will capture that at the initial stage itself, rather than waiting for it to exploit afterwards. The next one is the add role to instance profile. This is again, as you can see, like most of these events will have a common role, which is the WAF role. This is the highly permissive role. As you can see in the first log, it has a S3 full access, and then this role was further attached to the EC2 instance. The next one is the assume role operations. So naturally, you have seen that this role was assumed. This data was provided by the STS token service. The next one is the list object and get object. This will actually show any files that are accessed underlying S3 bucket. That will show like which files were accessed and then if it contains a sensitive data or not. Lastly, the get object will also show a field called as byte transfer out. So this is basically the number of bytes that were transferred while accessing these objects. So anytime you see a larger deviation from your normal baseline bytes transferred, you should monitor that. So let's talk about the detection opportunity. Definitely, as a blue teamer, you don't want to monitor any individual signals. The purpose here is to combine multiple signals or chain events together so that you can write a high fidelity detection. So these are some of the examples that we came up with while writing the detection. So the first one is the privileged role attached to the instance. So you can see like we saw the attached role event, which was a privilege policy was attached to a role, and then followed by we saw add role to instance profile. So you can write the detections basically attached role policy followed by the add role to instance, and then make sure that this policy is for highly permissive or highly permissive roles. The next one is the assume role. Again, this is something that you can look for like any historical context. If you know certain roles are highly permissive, make sure try to identify if this was any unusual activities happening which was historically not seen previously. There are also like suspicious data access from an unknown IP address. So if your S3 buckets are publicly accessible, try to monitor the source IP ranges and then see like if you see any unusual pattern. The data transfer anomaly is based on the bytes transfer field that we saw earlier. All right, so let's talk with the second scenario here, which is the IAM privilege escalation by attachment. So in this scenario, you are starting with existing user. So once you deploy the resources, you will automatically get credentials for this IAM profile. There may be multiple ways this might have got compromised. So in this attack scenario, you are starting with already a compromised profile. And then you start identifying what are the existing IAM instance profiles that are attached. Try to identify if there are any roles which has a full admin policy attached, and then you can swap that full admin profile with your existing IAM instance profile. Once you got the once you do the swapping, you can basically create a new key pair, spin up an instance, attach that policy which already has full admin rights, and then log into that EC2 instance, and then finally you can delete any supercritical security server. So these are some of the APIs that we can start monitoring. Some of these APIs we already covered in the previous scenario. A couple of new APIs are like create key pair, run instances, terminate instances. These are again mapped to the respective tactic and technique, so you can map your detection to the attack framework. Let's talk about the event log timeline here. So the first and foremost, again, we are starting with the CloudGoat action itself. So if you wanted to see an example of full admin policy, you can see that this is, let's see, we have a action which is star. The effect is allow and resources star. So basically, this is like any firewall policy, so it can perform full admin operations. So as part of this scenario deployment, CloudGoat has to create this policy, so you can capture this event and then write detections on this particular activity. The user agent, again, here you can try to identify that this is using Terraform and CLI interface. The second one is the attached role policy. Now we know that this policy, which is the name is given here, CG EC2 MITRE policy, this has a full admin rights. So now we need to move or like pivot our attentions to this policy. So anytime this policy is attached to any role, we should start pivoting to that role to monitor the further activities. So here we have seen that there is an additional role, that CG EC2 MITRE role, for which this policy was attached. As part of the cheat sheets, we have performed certain operations such as describe instances, list instance profile, list roles, to identify that full admin policy. So you can see here we have a describe instances, list instance profile, these operations happening from the user from which we actually started this exercise. This is the actual swapping operation. Here you can see this particular user you can see the timestamp is also like almost same, but basically you have observed the remove role operation first, which has a low privilege role. So this has a low privilege policy attached, and then this was removed, and then the new role which has a full admin rights was attached to the instance profile. The next one is the create key pair. So you can see like this user have created a new key pair, and then it started creating new instances. Once it logged into that newly created instances, it has performed a terminate instances for the supercritical server. Again, for the detection opportunities, few new things here, like full admin policy created, which was the action star effect allow restore star, and then immediately after policy creation, if you see it is attaching to a roles, user, or groups. So this is something very high fidelity detections that you should start monitoring it. Nobody should be creating full admin policies and then attaching it and then leaving it unattended in your cloud environment. Another one is the instance profile swap that we saw. So remove role followed by the add role is something worth monitoring. Create key pair, terminate instances are some on the lower priority, but it's worthwhile to monitor. All right, so let's talk about the last scenario here. This is fairly easy and a smaller one. So in the previous scenario, we saw privilege escalation by an attachment. In this case, we look into the rollback. So again, in this case, we are starting with the particular IAM profile called Brenner, and then this profile will start reviewing what are the previous versions of IAM policies that are accessible to him or her, and then once it identifies the previous version, it start looking at what that policy constitutes. Once it identifies that a particular version was created which had a full admin policy, and then that version was left in there and then not deleted, you can use the set default policy version to restore that previous version to get the full admin policy. So this is fairly small, so you will see like some new API operations here: list attach user policy, list policy version, get policy, and then lastly the set default policy, which is the actual privilege escalation. From a timeline perspective, again, the CloudGoat will basically show up the full admin policy was created. In this case, we saw create policy version API. So you can, when you're writing a detection for full admin policy, make sure you cover all of the associated APIs such as create policy version, or any other APIs. The next one is the list attach user policy. So once that policy was created, this was attached to this username. The next one is the list policy version. So this is basically the attacker is doing some recon to see like what are the policy versions are available. Once it gives the get policy version that you can see here, there are like different versions are available from V1 to V5. One of these version has a full admin policy that attacker is basically has identified, and then it is executing a set default policy version to basically restore that particular policy version and to get the full admin rights. From a detection perspective, you can clearly see there were like some recon with the multiple get policy version and then followed by the set default policy version. You can also have some kind of list which will contain the which will contain the full admin policies to monitor for this. Some of the detections that we already have developed as part of our previous scenario deployments. So that's fine. All right, so that covers our all the three scenarios. So what next? So I do wanted to mention about the project Simuland. This is an initiative by Open Threat Research Force OTR organization by Roberto. He recently joined our team, so we are very lucky to have him. So he has created basically a data set which was from the result of the first scenario. So if you go to the, if you know the modern data sets, so this is basically another project that is focused on the cloud data set. So the first scenario is already available. In case you don't have the environment to simulate this for in your environment, you can just go ahead on this particular website and then download the relevant data set and then start looking into how does that data looks. The project also has the playbook, so you will start with the simulation plan, data collection via the Kafka Cat, and then lastly you will also have a Jupyter notebook which will show capability to look into those logs. Lastly, some of the detections that we talked about, we have published on our public GitHub. Again, this is one of the ways that you can visualize the attack matrix. So in this case, instead of the heat map, I basically pulled in our all of the AWS detections that are available for public into the each tactics, and then basically associated severity for these each of the detections. We also have something called detection and hunting query, so you can distinguish there are like different hunting queries are available. So even if you don't have the Azure Sentinel, you can definitely go back and then see like how that logic was created, and then basically map that logic to your favorite SIEM platform or query language. All right, so that was pretty much that we covered today. So we saw like adversary emulation or vulnerable by design labs are very great way for purpose gaming on the cloud. It is fairly easy to spin up and destroy environments in the cloud since we have Terraform, ARM, or CloudFormation templates, which makes automation a lot easier. We also saw like by having the end-to-end attack scenarios, it gives us capability to develop like high fidelity detection. So you can combine or like you can combine different events with common entities, or you can have a chain sequence of events while writing the detections. As part of the purple teaming exercise, at the end of the exercise, you will also identify some of the logging gaps that will show and give you requirement to onboard any new data sources. The exercise will also validate your either your existing detections or create a new detections for cloud attack vectors. Again, lastly, we can monitor the CloudGoat action itself to detect the misconfiguration of vulnerable resources at very early deployment stages. These are some of the resources. Again, the slides are shared, so feel free to go through that. And then feel free to reach out to me via Twitter or any other social platforms. I'll be also in the Discord to answer any questions.